Join us as Honda R&D Europe's Martin Heiderich, Senior Project Engineer, explores the integration of Varjo XR technology with the DiM250 driving simulator. Discover how these advancements in virtual test driving enhance immersion and realism. Learn about the first-hand experiences and insights gained from utilizing Varjo XR-3 in driving scenarios. Gain valuable insights into the differences in driver perception and behavior between head-mounted displays and traditional projection setups.
Yeah, so hello everybody. It's a pleasure to be here. Similar to some other presenters, also my picture was a little bit old, so it looks slightly different now, but yeah, I work now for almost 12 years in the area of virtual vehicle development, especially now for around 10 years in the area of driver-in-the-loop simulation systems and driving simulators. And yeah, today I would like to share our experience in the area of virtual testing, immersion, enhancing the immersion in this field. So therefore, integrating the Varjo XR technology within our DiM250 simulator system. I will quickly start with a short introduction. What is Honda R&D, where we are located, how does our virtual test center looks like. Then I would like to continue with the simulator visualization systems we use in our virtual test center, integrating the Varjo XR technology and the challenges we had, and then finally some remaining challenges and an outlook how we will continue with this topic. First of all, Honda R&D is basically worldwide distributed. We have several R&D centers worldwide. Our main headquarters in Tochigi in Japan. We have Honda in America with the Honda development and manufacturing. We also have Honda in Asia as well as Honda in Europe. And in Europe, we have a location in Reading in UK, a small R&D office. And you can see in the center basically our R&D center, which is close to Frankfurt area, located in Offenbach. And yeah, our role in Germany within this global network is to be some kind of a global pathfinder, especially to develop new technologies, new methodologies, new workflows in many different areas. A unique item for our location in Germany is that we basically combine all the different departments in one location. So we have the automobile sector, we have the motorcycle area, we also have the solution systems like lawnmower and so on, and we also have our Honda Research Institute, which focus on new technologies which are far away from actually the product start. And in the automobile section, we really focus on powertrain units, electrification, digitalization, and we also have the vehicle dynamics department research, where we basically also focus on virtual development methods. And yeah, you can see here we have already a certain history using simulators. Already in 2014, we started many different evaluations regarding simulator systems, simulator capabilities. We started with vehicle dynamics evaluations. Which spec changes can we really feel? We tested several simulator systems. We used it for ride comfort evaluations. ADAS is a big topic, steering feel, and we also got already some quite good experience with biometric measurements. And based on all these experience, we decided in 2017 really to set up our own virtual test center in our German R&D center, so that we finally established the first DiM250 worldwide. And our role basically since then is to enhance the driving simulator technology and really also to create new virtual development methods. After setting up the virtual test center, we thought, it's also nice to have a good preparation place because the simulator is very busy. Then 2020, we decided to set up again a compact simulator. And also based on all our experience which we collected in the last years, then finally also our Japanese colleagues in Japan decided to set up the extended version of the DiM250, which is the first DiM300 worldwide, which is now used for vehicle development and research topics. I would like to show you on the next slide a little bit of an overview about our DiM250, our virtual test center, which is located in Germany. You can see in the center part basically our simulator room, where we have located our actuator-based DiM250 with our customized Honda Civic cockpit. And yeah, for us it was very important to have a very clean environment because we not only do expert tests, we also do a lot of customer studies within our research projects. So therefore, it was quite important to have a clean, soundproofed environment to also reduce actuator noise additionally. So therefore, we installed sound-absorbing pyramids. We have carpet on the floor and acoustic-absorbent ceiling, so to generate really some kind of an, I would not say living room atmosphere, but it should not look like a test bench. And on the top left, you can see the control room, which is on the first floor, basically, so that we have a very good overview over the whole simulator room. And with this setup, we are quite happy since 2018. I would like to talk now a little bit more about the simulator visualization system which we use. You can see here basically the importance of visual rendering. When we start with the driver inputs, basically we generate some vehicle reactions which lead to a vehicle behavior which then is distributed to the visual rendering, which then goes to the graphic PCs where then also the Unreal Engine is running, in our case using WorldSim nowadays, which generates the visual cues which then go to the driver. Motion is one of the important aspects. To have a very good motion reproduction, we use our motion cueing algorithms, which then control the motion system, generates the motion cues. Haptics feedback, I think most of you already tested here the shaker setups and also could experience the active belt to get some haptics feedback and haptic cues. And also sound is a very important, essential part where we use our sound models, which generates the sound cues, to have basically full driver immersion, which enables us finally to have a very good vehicle evaluation capability. And we need to know, and we already know from literature, that basically the visual rendering, the visual flow influences 80% of our motion perception. So it's a certain important channel which has a high influence on evaluation capabilities. Therefore, on our DiM250, we basically use 5 barcode projectors, the F70, where we have around 40 pixels per degree with 260-degree field of view, and our graphic PCs have a latency of around 25% using the RTX 3090. On our compact simulator, we use the Barco F80, also here field of view of 70 degree. We use here already in 1490 and could reduce therefore the PC latency, but still we use projection systems which comes with certain limitations. In general, system latency is a big issue, PC latency plus display latency, but also projector illumination and brightness. We have our human retina resolution demand, which is in the area of 60 pixels per degree. Static screens are somehow limited, so when we think about future driving simulator systems, we would like to enlarge the workspace, but still keep the high performance of such a DIM system. We also need to think about new visualization approaches, which are suitable for all our applications. And there's a certain missing part in terms of depth perception. We use projection systems with 2D dimensional DIM images. So there are also certain aspects missing compared to the real-world visualization. And this is what we see here, issues which we noticed in all our last projects. Basically, speed perception. We did many, many tests, and in general, we can see there's a certain underestimation of speed. On the right side, there's some examples where we tested in different scenarios. The driver did not have any idea how fast they drive because the speedometer was covered. The target speed was to drive 120, and you can see basically almost all people drove faster based on their perception. It leads basically to a faster to a 20% faster driving. Distance judgment is a big topic. We noticed in autonomous driving scenarios, for example, that around 80% do some kind of overestimation to the distance in terms of the distance to the vehicle in front. And this leads also to misjudgments during the evaluations. And the last point is also sense of presence and immersion. It's highly influenced by the projection system or visualization system in terms of lighting, shadowing, contrast, because we would like to be close as possible to the real condition. And we also did many tests using Open Scene Graph in Scania environment, but also Unreal Engine. We could see clearly that 88% prefer the physical-based rendering which we have in Unreal Engine. And we need to keep in mind that also projection systems have certain disadvantages because they reflect the light source. LED walls and head-mounted displays are their own light source, so therefore we can get much more colorful pictures and much more contrast in the visualization. And this is exactly the reason why we started to think about what can we do to further improve the visual immersion? And in the last years, we could clearly see that head-mounted displays had a quite strong performance improvement, especially in terms of display latency, which got better and better. The resolution and pixel per degree were much more natural, closer to the human eye demand, and also the ergonomics increased or improved a lot. You can see in the table a little bit some head-mounted displays where we had a closer look. And finally, we decided for the professional systems like the XR-3 from Varjo and also the XR-4. We also had a closer look on the X-Tile with a much wider horizontal field of view. And yeah, luckily also VI-Grade started to implement the XR-3 as well as in future also XR-4 into VI realism, which allows us basically an almost uncomplicated implementation in our DiM250 environment. Big advantage, I already mentioned, we have with head-mounted displays now instead of 2D, the stereoscopic vision, 2 images, 1 for each eye, which is much closer to the real impression of the real world which we have. And an important aspect is cost. Such a professional system is less than 5% of a conventional projection system, which has a quite high effect on the investment. So we think that there is a certain potential using head-mounted displays in future, and this is exactly the point which we investigate currently in several projects. We did a proof of concept already 2.5 years ago, where we started with Scania Studio. We used the OpenXR interface, connected the Varjo XR-3 on our compact simulator, used the Lighthouse Steam VR tracking, and then basically did first tests to see the performance of the Varjo systems within this virtual test environments. We also took care for the steering and hand visualization using the Varjo depth occlusion as well as the Varjo masking, and could see already in some studies that really already the application of VR, even an open scene graph, provides a quite significant benefit. And also here we could see that 62% prefer in VR also the Unreal Engine rendering. We also did many subjective evaluations with expert drivers, and we could clearly see that speed perception, distance judgment, vehicle speed controllability, as well as the sense of realism could be drastically improved compared to the projection system. But of course, we also noticed some issues. For example, increased sensory conflict. We talk here about the compact simulator. We don't have any movement, but it's a certain aspect which we should keep in mind. Display latency, rendering performance. There's a higher demand when you use VR systems in terms of computer performance and so on. There's still some room for improvement in this area, and we really try to also push the industry a little bit in this direction to further continue these technology researches and improve this step by step. Due to the issues, we decided to continue our tests on our DiM250, especially in terms of the sensory conflict. So therefore, we set up basically a high-performance graphic PC with latest graphic card 4090, as well as Intel i9 14600, and set up, or 14700, sorry, and set up this system based also on the recommendations by VI-Grade, together with the WorldSim rendering engine. We use here on this computer also the Varjo base software, basically to get the information from our head-mounted display. And then we use the LPVRDO sensor fusion software from LP Research at a Japanese company, which take care basically for the sensor fusion of an optical tracking system. You can see here on the windshield, on the bottom left picture, the SmartTrack 3, which is an optical tracking system. We use the Varjo IMU data, and we have to compensate somehow the platform movements. And this is why additionally there is an IMU mounted on the platform itself, and overall then the sensor fusion algorithm calculates a very accurate pose. We were quite surprised about the quite accurate tracking. So in previous setups we got a lot of steps inside the movement, so it was not very fluent. With this setup now we are quite confident that this is a very good solution for the future. We did many experiments so far. Typical evaluation scenarios are straight driving on a 3-lane straight. For speed perception evaluations, for example, here we still also on our big DiM system, we could see that with 260-degree field of view, we still have an underestimation of speed. This was much better with the Varjo XR-3 and XR-4 because we have this depth perception and much more environment information available, which then is much closer to reality. Distance judgment, also during cornering, for example, is an aspect. Before with the projection system, it was a little bit difficult really to have a very accurate trajectory guidance with the head-mounted display and the much more fidelity in the environment. We could significantly improve the trajectory guidance. Also, when we think about future applications, or maybe also exchanging projection systems with head-mounted displays, we also need to keep in mind we also have other scenarios like ride comfort tracks. So therefore, we also did some initial evaluations if we can use head-mounted display for ride comfort evaluation. And yeah, it's some kind of an issue because you have a big mass on your head. So that means on ride tracks, especially if you have quite big road excitations, quite a lot of heave and bounce movements, you really have to fix it that you don't have too much movement in the visualization. And this quite high fixation creates some discomfort. And we also have to keep in mind it's a quite high additional mass. It's 1 kilogram, which sounds not so much, but it's like if you drive on a proving ground and you wear a helmet, this also influences the subjective evaluation capabilities. But in general, we also could confirm here our results from the compact simulator, so we can really see the potential. There are still some improvement items, like the display latency, where we are currently in the area of 25 milliseconds to 30 milliseconds, depending on the content within the scenario. Also the FPS stability, so the frames per second software side. I think VRGrade is working hard on this topic, but yeah, there's still room for improvement, but we can clearly see the potential. Challenges and outlooks. Basically, I mentioned already the discomfort during ride evaluations. This is something we probably cannot change a lot just by using the latest head-mounted displays. Also, the industry needs to create high-resolution displays with quite low weight, for example. There's one issue also which we noticed in terms of limited field of view. The human demand, for example, in horizontal area is 200 degree. In vertical direction, we have around 130 degree. Head-mounted displays basically are a little bit limited, especially the Varjo systems. So they have a horizontal field of view of 115 as well as 120 degree. So also here, there's still some room for improvement. Latency of current head-mounted displays, I already mentioned, still a little bit high because a lower latency is clearly preferred, especially because it has a high influence on cognitive functionalities, such as sense of presence, spatial cognition, and situation awareness. Also, one item which is some kind of an issue which we also cannot influence, it's the divergence accommodation conflict. And this leads really, after long driving duration, to eye strain, blurred vision, and headache. It's basically, you can see it on the right side in real world, when we have a closer look on an object and we focus on an object, the distance of vergence, so basically how our eyes rotate to look through an object, and the distance of accommodation, so basically the focusing, have the same distance. If we talk about VR displays on the bottom right, we can see that the distance of accommodation, so the focusing point to the display, is much closer to the eye, and this mismatch basically is again a sensory mismatch and leads to really some issues during driving. The last part is motion sickness, virtual reality sickness. We noticed in some tests really that many people are quite sensible on this topic, and we really have to think about how we deal with this when we plan to exchange projection systems with head-mounted displays, because also the visual demand is higher with head-mounted displays. And we also need to keep in mind when we still use these high immersion, our platform movements are still limited, and we have the sensory conflict between visual and motion. So we will continue working on these topics, especially investigating the potential of XR3 and now also XR4 a bit more in detail with the official release of 2024. We will also have a closer look on virtual reality sickness investigations, especially when we talk about longer duration drives, and we will also derive future requirements for our next Honda cockpits as well as visualization systems. And yeah, this brings me to the end of my presentation. Thank you very much, and I think if there are some questions, I can answer or also answer later.